Welcome to Maritime Matters, a podcast focused on leaders in the maritime market, the people, the companies, the technologies that are making and breaking the news, helping to lead the maritime industry to a safer, more efficient, more profitable, and cleaner future. Welcome aboard. This is Greg Troutwine with Maritime Matters, the Marine Link podcast, and we're very pleased to be joined today by Heather Carroll, the Chief Revenue Officer, Path Robotics, to take a deeper dive into this company and its aspirations to be a major player in the bid to rebuild shipbuilding capacity in the United States, and in fact, a driving force for automation in shipbuilding globally. So Heather, before we get into the tough questions, welcome to Maritime Matters.
Thanks, Greg. It's very excited to be here. Really looking forward to this conversation. It couldn't come at a more important time, just where we're at right now in the industry and as a nation. So really excited to have this conversation today.
For listeners hearing about Path Robotics for the first time, what is the company's origin story and what problems were your founders trying to solve when they started the business?
Yeah, so we were founded about 10 years ago by two brothers out of Columbus, Ohio. They were born and raised in Ohio. Manufacturing was in their blood, and they had gone through school and were working on their PhDs. And one of them was in bipedal humanoid robotics, so how to get a humanoid to walk back 10 years ago before humanoids were all the rage they are today. And then his brother, Alex, was working on his PhD in computational neural networks, how to get a neural network to think and work more like the human brain. So when they got out of school, they both kind of looked around and said, what can we do to solve a real world problem with this AI technology that is really starting to come into its own and really be able to solve problems, complex problems in a real way. And when they looked around, they didn't want to leave Ohio. They really wanted to take that learning and take everything they'd gone to school for and try to help the manufacturers, just like their dad, who had a fab shop. They started welding at 8 years old in their dad's garage, and they saw how hard it was to be a manufacturer, and with all of the stuff being sent offshore and the whole center of the heartland being gutted for manufacturing jobs, they really wanted to figure out a way, how can we help bring this back and revitalize it? So they focused on welding, and they started the company with this idea that we should be able, using reinforcement learning and AI, to teach a robot how to weld like a human learns how to weld. And so they started doing that about 8 years ago, had kind of the first product out in the market, and has just been going like crazy since then. Turns out welding is a really, really hard thing to do, and it's a very complex thing to do, but it is absolutely necessary and critical in all manufacturing. So they spent about 8 years really collecting data, and that's the key to physical AI, is you've got to have real world data to make it work. And that's part of the reason that it really hasn't advanced as far as some of the other fields in robotics. But what they've been doing is collecting data in manufacturing facilities across the country for the last 8 years. And that data has been used to go back in and create reinforcement learning that is enabling us to really be able to teach the robot to look at a seam, understand what it's seeing, what are the gaps, what's the fit up like, and how to create a fill plan and then start welding and adjust in real time. And that's the key differentiator that Paths have been able to solve for.
That's an amazing story, and there's a lot of touch points to go just on that opening statement because I too am born and bred in Ohio, although I certainly don't have my PhD, and I know just about enough about manufacturing technology to be completely dangerous. But I grew up in Southern Ohio, and my father was actually a tool and die maker for General Motors. So I am very well into the manufacturing process and the importance of efficient manufacturing. So,
Yeah,
and I,
I'll tell
go ahead.
you another kind of funny story.
Yeah.
So we were talking earlier, as most people can tell by my accent, I'm not from Ohio.
Yeah.
I live in Nashville. But when I first got the opportunity to talk to Path, I've been here about a year and a half, almost 2 years now. And when I got the phone call, I spent about 20 or 25 years in AI and robotics, but in supply chain and logistics. But my husband is a welder. When we got married 32 years ago, he was a welder. And over the years, he ended up owning his own manufacturing facility in Nashville. And I watched him just struggle with particularly the welding labor. That was the one department that was the bottleneck for really scaling his business. And after about 5 or 6 years in the boom of construction in Nashville, he had an opportunity to sell the business just simply because he couldn't scale it any further due to the skilled labor shortage, particularly in the welding area. So when I got this call of, hey, there's this company that has this great solution that will help manufacturers like my husband's, who I saw every night come home just stressed to the nines over how to deal with this capacity and throughput issue. It was a real opportunity to take something and maybe really make an impact and help people like my husband's company and others.
Before we get into like doing a full breakdown of the company today, I saw that Path Robotics described itself as a physical AI company rather than a robotics company. Simply, does that distinction actually mean in practical terms?
Yeah, so when you think about traditional robotics, most people have a picture of, you mentioned automotive. Most people think of an automotive line where you've got these arms and they're in a fixed position and the assembly line rolls up to them and they're just doing things, the same thing 10,000 times in a day. And that works really well. That's traditional robotics where you've got that robot programmed to expect something to arrive to the robot and for the robot to perform the exact same process over and over and over again. Physical AI is different. What physical AI is doing is it is combining the ability to put sensors, vision, camera, and intelligence onto that robot so that it is able to see what is in front of it, make an assessment of what it's looking at, understand what is the seam, what is the joint type, the material type, look at all of the inputs, and then create a field plan and execute on that field plan. So that physical ability to combine sensing capability, intelligence, and the robotics movement, all of that combined is what makes physical AI.
Absolutely amazing. And again, I appreciate that insight. So, let's go back to Path Robotics for a moment, because I know for many watching this, it is a new name or a newer name. But can you give us a by the numbers look at Path Robotics today? And with that, I'm just looking for key data and statistics that give our audience reference to your shape and size.
Yeah, sure. So like I said, we're based in Columbus, Ohio. We have about a 200,000 square foot facility there where we um, have most of our operations. I'm in Nashville. We got a couple of people that aren't in Columbus, but for the most part, all of us are based right there in Columbus. We've raised about $370 million to date. We have a little more than 250 employees. We are expected by the end of the year will be between 350 and 400. And when it comes to revenue targets, what I can say is in 2025, we quadrupled our top line revenue and surpassed $100 million in bookings. In 25, we're expected to 3x that this year in 26. So we are growing like crazy. We focus primarily on three core verticals. Those are heavy infrastructure. So think things like grid modernization, heavy moving equipment, heavy construction type equipment, things that need big, big parts that need lots of multi-pass weld. That's kind of our sweet spot. And then the second vertical we focus on is AI infrastructure and data center construction, an area that is just booming right now and suffering mightily from the skilled labor shortage. And then the third is shipbuilding. We started our government solutions team last year with a focus on taking the technology that we've had commercially in the market for the last 8 years and bringing that into the shipyard.
Let's look specifically at shipbuilding because that's what we're here to talk about. And I know that Path Robotics is not simply another robotics welding company. Can you walk us through the touches in shipbuilding today, the partnerships, the trials, the installations, with insights on where you're at, but more importantly, where you want to be in the coming 12 to 36 months?
Yeah, so today I'd say we're working with major shipbuilders. Back in February, we signed an MOU with Huntington Ingalls. Um, that then turned into an announcement at Sea Air and Space in April that Huntington Ingalls had selected Path as their hyper partner. Hyper is their high yield production robotics solution. So we are their physical AI partner for welding, as well as a few other things that we're going to be doing as part of that program. We also are working with Saronic in their Franklin, Louisiana yard. That is where they're building the aluminum vessel, the Marauder. We're their physical AI welding partner for that solution as well. Then we also have some commercial shipbuilding customers. One in particular is LAD out of Morgan City, Louisiana. They build barges. Most people, when I describe that, think of SpaceX. So they actually do the barges that SpaceX launches from and lands on. So very technical and very hard structured welding that's required for the amount of heat and weight that's required for those types of launches and landings. And so we work with LAD out of Louisiana as well. Yeah, and I think when we look at this space, when we initially came into it, we're very focused on the physical AI manufacturing, primarily in welding. And we're looking at it from what we're seeing in the industry in other parts of the manufacturing industry. And how does that relate to shipbuilding? And how can we translate some of those wins and successes in commercial manufacturing into this space? And the number one thing that when I talk to manufacturers about automation and what are barriers to automation, why, welding automation is not new, it's been around 50 plus years. So, why now is it the time that we can start bringing these technologies into the yard or onto the manufacturing floor? And it's just critically important because we do not have the people. Like, we absolutely do not have enough skilled labor for the demand that we're seeing right now. And the demand is at an all-time high. When you look at shipbuilding in particular, we have a $1.5 trillion defense budget that the president's put forth. Commercial shipbuilding orders are up 40% year over year just for commercial ships. And then you've got all of this demand that's being generated by the other sectors of the market that we serve, heavy construction and AI infrastructure. When you look at those three sectors, you've got 1.5 trillion in defense. You've got $1 trillion just from five hyperscalers in building AI data centers. All that stuff has to be welded. It's the same multi-pass type welding. And then you've got $1.2 trillion in the infrastructure bill that Congress passed in order to modernize the grid and do all of this construction. So now you've got three different segments of the market all vying for the same welding labor. And it is just, we're seeing it in the yards. What's happening is we have massive turnover because they can go from the shipyard to building in a data center and make the same or more money and not be in as harsh of an environment as they are in the yard. And so this interplay between the demand that we're seeing across these industries for this same very small labor pool is really hitting shipbuilders harder than I think most people anticipated.
Let's take a little bit deeper dive into the recent agreement with HII, because that obviously, once you sign on an HII, that's going to generate a lot of attention. Without, of course, discussing the proprietary details, what specific shipbuilding challenges are you hoping to solve together?
Yeah, we're working very closely with the HI team to collaborate on ways that we can help them increase their throughput and increase production capacity. And one of the ways to do that is this concept of distributed shipbuilding. So, are there different parts of the ship that can be made somewhere else and then brought to the yard for final assembly? What that will do is unlock capacity from a constrained yard by taking components like foundations. like subassemblies, things that could be made elsewhere and then be trucked or barged into the yard for final assembly, will allow additional capacity to be unlocked. And so that's part of what the hyper program is taking these subassembly parts that could be distributed and then use automation to create those parts in areas where it's really difficult to find the labor to do those specific types of welds. The other thing that a lot of people, I mean, if you are in a shipyard, you know this, but if you're not and you don't know a lot about welding and you hear these big numbers of we need 850,000 skilled laborers in order to meet the demand of shipbuilding. But when you look at what it takes to become a welder and to be NAVC qualified, you have to go through that qualification every 6 months. And it's not easy. And it's not something that you can get someone off the street, throw them into a technical training course, and in 6 weeks have them welding. To weld on a nuclear submarine, it could take you 6 to 8 years to get the skill level that's required to do some of these very complex multi-pass welds. And that's the kind of thing where we don't have enough time. We have this retirement of labor happening where we're losing people faster than we're bringing new ones in. And we've got a job that requires high level of skill, lots of training and lots of time in order to be able to be certified to do it. So those are some of the areas that we're working with Huntington Ingalls to figure out how can we take the welding labor they have and augment it and help them do more with what they have today.
Let's talk more specifically about the company then. So how has the company evolved from its early welding system to today's Obsidian AI platform, and what have been the biggest technological breakthroughs along the way?
Yeah, I think Path has seen the same trajectory that a lot of others in the AI space have seen. There's really two things that you need. There's a lot of stuff that you need, but there's two things that you need a lot of in order to make an intelligent system really autonomous, and that is compute power. It's got to be able to compute things very quickly, and the second is data. And without those two things, your system's just not going to work well, and you're not going to get great results. And what we've seen over the last 8 to 10 years since we've been doing this is the industry has come along with us. The compute has gotten faster, the sensors have gotten better, the camera technology, the ability to see inside the weld puddle, all of those types of capabilities and tech have really had leaps and bounds. So that's enabled us to be able to take what started very early with a few manufacturers collecting this data to now take this data, and we've got millions and millions of inches of data on actual welds that are happening. So think about with our sensor package and our vision system, we're able to look at the joint and scan the joint before the weld starts. We create this fill plan based off of the WPS from that customer to say, okay, these are the parameters for how we expect to fill this type of joint with this type of weld. We create that plan. But what's different is while we are welding, we're able to see inside the puddle. We're using about 17 different inputs. So think of things like amperage, voltage, temperature, torch speed, torch angle. And we're able to look at this. We even have audio sensors where we can hear the weld. And so all of that data is taken in over millions and millions of times that we've welded. And we're able to train a model and say, this is what you can expect when you see all of these things and you have all of these parameters changing in real time. And then we're able to adapt. So as we're laying down that first pass, we're able to look at exactly what was laid down and make any adjustments required for each pass that's going through. So the true capability to adapt is there, which did not exist before. But that was only possible by having sensor technology that can sense things that we weren't really able to 10 years ago, having compute capabilities where we can make decisions and move fast enough to be able to do that in real time to provide that real time feedback. So those are some of the things that have evolved over time, producing much better quality and much better autonomy of the system. I think it gets back to Andy and Alex, our co-founders, kind of original premise was, can we teach this robot to learn to weld like a human learns to weld? Not can we teach it to weld like a human, but how does a human learn to weld? Well, it takes time. It's just practice. You just do it over and over and over until you learn that if your temperature is not right, you're going to have this happen. You learn that if you're doing a very heavy deposition weld on heavy, heavy, thick plate, you're going to get distortion. And so you learn to do things like jump around, where you weld here for a little bit, then you go down here and weld so that you can minimize the distortion. So by training a system, not just to look at a CAD file and say, here's a point in time, I'm going to go here and I'm going to find this joint and I'm just going to follow this seam and I'm just going to track whatever the seam is. That is not what our system is doing. What it is doing is it is truly adapting the way a human would adapt. A human welder is not going to just put the torch down and just follow a line. A human welder is going to be looking for what are things that are variants that are changing in real time as I'm performing this weld. And they're going to reason and make adjustments to that. And that is what the Path system is doing with its adaptive capability. Is it's getting the ability to train on this massive data set where it has a playground that it can just go and do reinforcement learning, and it can try these welds in this simulated environment with real world data. And that's the key difference. It's very different than if you think about fit up or assembly or dexterous manipulation. That data is pretty cheap to get and pretty easy to get. You can go out and have people performing that same kind of task over and over, and there are lots of companies that will help you go collect that data. Welding is very different. Once you take those two very thick plates and weld them together, you're done. You can't do that again, and it's very expensive. And so there just isn't a lot of real data out there, which is what's kept it from being automated for so long, and particularly in shipbuilding.
When you look at your product portfolio today, what does it look like?
Yeah. So today we have our what we call our worker cells. And so these are fixed cells that are, think of them as having a six-axis robotic arm that is on a track that can move. But it's fairly a fixed footprint. It's going to be working within a specific area. So that's the majority of our deployments and portfolio today. In April, we launched our first mobile platform, and that's our product called Rove. And Rove is a quadruped that can walk around the yard or the facility in your manufacturing facility and walk to the part. So no longer do you have to bring the part to the worker. You can now take the worker to the part. And this is a game changer for shipbuilding. This is part of the challenge. You've got these really, really large parts that you cannot easily move around the yard. And that is part of why it hasn't been automated in the past. So having something that is mobile and can go to the part to perform the weld is pretty game changing. So we launched that in April. We've taken pre-orders for Rove. We had a goal of what we were going to sell to in the pre-orders, and we will hit that and surpass it by the end of the year. And then we're going to have our first deployments that will be going out the end of Q1, early Q2 next year will be the first production deployments out in the yard.
That's
And so we're talking
fantastic.
about Saronic. Saronic was our launch partner for Rove.
Talking about the robotics, and again, we talked about the shipbuilding environment. You've talked about it's been there for years. This is not something new we're talking about. It's been used for panel lines and highly repetitive
Mhm.
tasks. Looking at shipbuilding as a whole, in your opinion, why hasn't conventional automation spread much further into shipbuilding to date?
Yeah, I think it has a lot to do with this concept of not being easy to bring the part to the robot, to the automation. And it's really twofold in my mind. That's one big, big piece of it. You just, I mean, you go out to these shipyards, this stuff is huge. And moving these things around takes massive cranes, takes lots of people. Um, and the idea that you would have some type of line that you would move these parts to and then it would weld in place, and then the next thing, it just doesn't work that way. So that's the first, it's just the general size of what you're dealing with. And the second, it gets into this lack of intelligence and ability to adapt. These parts, when you're bringing these two massive pieces together on a ship, it's very gappy. It's not laser cut and perfect every time. There's all kinds of issues with what you would, that if you had a CAD model, what it would tell you to expect is going to be very different than what actually shows up when you're trying to put these two pieces together. And traditional robotics cannot handle that. They're pre-programmed. They expect a certain level of accuracy to whatever that program has assumed. And if it hits anything that is not exactly perfect like expected, it will fail and it can't produce the weld. And so that lack of adaptability is the second reason that we haven't seen more automation in this space
Okay.
until now.
So when you look at the Obsidian, then how does Obsidian enable a robot then to see, think, and adapt differently than a traditional industrial robot?
Yeah, it gets back to that data set,
Okay.
because the same way, had you had years and years of experience of cutting that crown molding, you would have known what to expect and maybe measured twice, all of those great
Maybe.
things. Maybe, maybe not, but it's that data set. It's think about it as the experience. So if you look at Path's deployments, we have all of these robots that are out in the field and they're making all kinds of massive parts today, heavy moving equipment, mining dump beds for dump trucks, backup diesel fuel generation, utility poles, just all kinds of stuff that we have robots that have been out there for 8 years making thousands and thousands and thousands of these things. All of that data goes back into the same model. So now you've got this brain that can be put on this robot that has been learning for 8 years, but not like one human welder, but like hundreds or thousands of welders. It's every single weld that we've got in excess of 10 million plus inches of weld that has been put down. And that data has just been used over and over to reinforcement learning to improve the model. And so that's the difference. And it's again, like I said, it's extremely expensive data to get. You're not going to find companies that can just afford, no matter how many billions of dollars they raise, to just go out and try and start welding all these plates together to create this data. And we recognize that very early on. And so by being able to deploy with manufacturers across multiple industries, across different product types, we were able to get this really rich data set to use this reinforcement learning with. And now that data set is fairly enormous, at over, like I said, over 10 million inches today, just in that one data set that's driving Obsidian.
So when you or your colleagues walk through a shipyard today, and the beauty of a shipyard is there are all different shapes and sizes, no matter where you go around the world. No two are rarely the same. Which fabrication processes immediately stand out as the best candidates for physical AI?
Yeah, I think what we look for and what we help the customers look for are, where are the areas that you're bottlenecked or constrained. I have a great example. Recently, I was at a yard, and oddly enough, we were on the panel line, and we were coming through and walking past the panel line. And at the end of the panel line, you had all of these people that were, this is after the automation. You have all of these people that are welding at the end of the panel line manually, and they're just laying all over the floor trying to get to these welds that the panel line wasn't able to do. Now, you've spent a bunch of money, you've put this really nice equipment in to automate the panel line, but then at the end you're bottlenecked because you've got this constraint of these welds that the machine can't do. So you have humans having to come and do that. But if they can't keep up with the rate of the equipment, then you're getting a bottleneck and you're not leveraging the equipment, right? So when we work with a yard, we'll come in and say, okay, where are your bottlenecks? And are those the types of welds that one, we think that we can get to, and two, we could do in a much faster way than how you're doing it today, then that would be a great candidate. And so that end of the panel line is a great candidate for something like Rove. You could have 10 to 20 roves that you deploy to the end of the panel line if it's starting to get backed up. You can have Rove do those welds on the ground at the end of the panel line. And then when you're caught up, move Rove to a different area to work on some other bottleneck in the facility. So what we're looking for is just where are your biggest pain points and constraints that gum up the rest of the process? Because oftentimes that is what is limiting capacity, is the flow of the work. You can get really fast in one area, but if it just gums up the rest of the system downstream, you're really not helping anything. And so that's one thing that we look for, is where are the bottlenecks and constraints that we could put the automation in, help augment what the humans are doing in that area today. Is there a certain type of weld that's really skilled and it's really hard to find someone to do? Is that something that the automation can handle? Then that would be a great candidate. So it really varies yard to yard, but the premise is, where are you constrained? Where are your bottlenecks? And is it a good fit for the automation to be able to help you relieve some of that pressure in your overall workflow process?
I'm going to switch gears here a little bit because we talk about technology ad nauseum infinitum across all that we do. And we also talk about the lack of people. And so whenever automation is discussed, people worry about job displacement. So how do you respond to the quote unquote fear that robotics will replace welders rather than support them?
Yeah, I tell people first and foremost, when you go to a shipyard, you do not have an abundance of welders. I've yet to go to one that has said, I've got too many welders. They're just abundantly available, and this is not my problem. So that is not what I hear. And I understand the fears and I understand the concerns, but um, historically, when people have been afraid of automation coming and taking their jobs, it's been when the conversation is far more about, how do I cut costs in my production and how do I shift that cost? That is not what we're hearing in shipbuilding today. The conversation isn't at all about cost, it's about capacity. How can I get more and how can I do it here? Because the doing it here is what's most important to American workers. If we can build more ships here, we can have more jobs here. But we can't do that if the critical constraining skilled labor doesn't exist. And so this is about augmenting that really, really painful part that we've talked about, can take 6 to 8 years to train someone to do well. Let's augment that, step in that gap now, and help bring more jobs back instead of offshoring and sending the shipbuilding to other countries to do, because we don't have the industrial base to do it here. I talked earlier about, when I talked to manufacturers, about what are the barriers to automation adoption for you? And it's oftentimes two or three things that stand out the most. One is demand signal. Am I going to have enough demand? If I automate, am I going to have enough demand 2 years, 3 years from now to justify having that automation? Well, we can take that off the table. We talked about those numbers. We've got $6 trillion in investment between shipbuilding and defense, commercial shipbuilding, data center and infrastructure, and grid modernization. By 2035, we will have $6 trillion invested. The demand is there, so we can just take that off the table. The second one is, am I going to be able to find the people to do the work? Am I going to be able to staff a second shift? Yes, maybe I can get all this demand, but I can't run a second shift because I can't find the people that will work on that second shift in my area. That's where automation can help. Let's augment what you're doing and enable you to be able to run more than one shift a day. So that's the second thing. And the third is, I don't have anybody here that's technical enough to be able to run a robot. No one on my manufacturing floor. It's too complicated. I can't afford to lose the space. It's too much. Well, that is where companies like Path and others that offer solutions that are autonomously driven, that do not require you to have a robotics programmer on staff. Everything is done by Path, and it's done autonomously with the AI. It takes some of those barriers off the table. And to be honest, if we want to compete internationally with countries like China for these types of jobs, we are going to have more distributed shipbuilding. We're going to have more of an industrial base in order to stay competitive. And I think that's probably the most exciting part about what I get to do and talking to people is having these conversations of how can we help you be able to do more in your facility, be able to capture this demand in a way that is productive and adds capacity and helps us remain and stay competitive globally.
That's absolutely amazing. And again, I appreciate that insight. So, I know you talked about it previously about the utilization of Path Robotics in the actual shipyard environment. But just to kind of crystallize it in my mind and the mind of our viewers, listeners, I guess what does the technology actually look like on the shop floor? Because you have the robotics, I'm assuming you're still having your traditional welders on hand. But I guess how does the role of the welder evolve when physical AI enters the process?
Yeah, so it's a great question, and the way we see it evolving in the real world, and I'll tell you, I out of all the customers we have, I've yet to have a customer that has told me that they have laid off any of their welders or fired any of their welders because they brought this automation in. What they do is they move them to higher value work. So the technology is not able to weld every single part, every single seam. There are some areas that you have reachability issues. So there are these limits currently with the automation that is the perfect use to have a very skilled welder that you do have on staff take those higher value, more complex tasks that maybe the robotics and the automation can't do yet. The other thing is to upskill that workforce so that they're able to run the automation. Um, some of our best operators are the ones that understand welding, so they know what it sounds like when there's a problem with the gas in the cell, right? They know, so they can intervene early because they can hear the difference. Doing higher value tasks around inspection, making sure that the fit up and the material being brought into the cell and getting ready for the robot is proper and the way that it needs to be in order for it to be successful. So there's lots of different things that can be done with upskilling and making the job of the welder, allowing that to be more of the high value tasks than the just repetitive things that are done that the robot could do over and over.
Beyond labor availability, what are the measurable business outcomes that customers can expect to see or are seeing? And again, whether that's throughput, first pass quality, rework reduction, schedule performance, cost, any all of the above or something not mentioned. I guess when your
Yeah.
clients are looking at the systems and look at those outcomes, what's top of the list?
Um, Better predictability is
Okay.
kind of the biggest outcome that you're looking for because in a lot of cases when you're dealing with turnover rates, we're seeing in some areas as high as 70% turnover.
Mhm.
I'll have people tell me if I hire 10 welders, then 6 months from now, I'm going to have seven that have left, and I've only got three left. So that creates a lot of uncertainty and unpredictable flow across your manufacturing throughput. And so that predictability is critical, and it comes with better cycle times. So you can rely on the cycle times that you've put into your model in terms of how long it's going to take to get this part through production. And it's better use of the skilled labor that you do have and greater confidence in hitting your delivery schedules. Um, I haven't seen this as much in shipbuilding as I have in some of the other industries, but we're starting to see in the data center world massive penalties for delays. And it's because the market is punishing these companies mightily when they miss their data center dates. CoreWeave, very famously last year at Q3, they had 136% year-over-year growth. The next day, their stock dropped 16%. It made no sense. The reason it dropped was they had an announcement that they had a third party vendor that had a labor shortage and missed a key delivery date for a component that they needed to turn the data center on. And so that schedule delay cost them a 16% drop in their stock price. So what's happening now is these hyperscalers are putting massive penalties into their contracts. Daily penalties if you're late on a delivery. And so that's the kind of thing where you need predictability in your operations and your workflow in order to make sure you can stay on and hit your schedules. And I think we'll see more and more of those types of things coming into shipbuilding, particularly when we're talking about defense.
I know we talked about shipyards a lot already, the differing sizes, the differing shapes, the differing capabilities. When you look at Path Robotics, I mean, is there a sweet spot? Is there a certain size or shape of yard that you really would excel at? Or even if you can't talk about a quote unquote sweet spot, can you give a little guidance on return on investment, which is, of course, topical to everyone watching?
Yeah, I mean, I think generally you need to have meaningful volume at the yard in order to automate. That's going to be true for anyone. Um, but I would say the size of the yard is really not going to be the thing that matters. We've got customers. We talked about Huntington Ingalls. They do aircraft carriers. They do really big things. And then we've got, customers that do, smaller mid-sized vessels. Like Saronic's Marauder is in that 160-foot category. So it's not the size of the yard that matters as much as the type of welding that they're doing. Are they doing heavy fabrication? Are they doing things that require multi-pass welding with gappy fit up? Do they have labor challenges with their welding workforce? Those are going to be way more critical and important than the size of the yard. And the ROI, I think the way to think about the ROI, one of the things that I love about our commercial model and how we work with customers is we will sit down with them and understand what it takes in cycle time to complete the parts that they have today. And then we will run that through and show them this is the cycle time that it would take if you ran one shift, two shift, three shifts with the automation in parallel. And then we're able to build out that business case. And in most cases, we see no less than a 35% savings on their existing labor spend. And so that's very compelling. If you're only running one shift, you don't have tons of volume, it's probably not going to make sense. But if you've got more demand than you can handle, you can't staff a second shift because you can't find the people. You've got too much volume for the one shift you have. You have all these inconsistencies. You have all this part to part fit up issue. Then it's probably worth having a conversation.
When you look 5 to 10 years ahead, what does AI-enabled shipbuilding look like from where you sit? And is welding the first step, or do you envision this being applied to fitting and assembly, inspection, or other fabrication processes?
Yeah, I think welding is the first step, certainly for Path. It was the place that we felt we could have the biggest impact. And if we could tackle the hardest thing first and get that right, then moving upstream and downstream from welding would make sense. So, fit up is definitely something that I would say is likely to be the next area you would see Path and others move into. But it's certainly something that we're working on currently, is expanding into that fit up space. And then I think there's other processes that naturally lend themselves to an autonomous AI driven solution. Things like inspection is likely to be a very good use of the technology. And then there's other areas that are being done very well by some companies out there today with the sanding, painting, grinding, some of those different types of functions. So I think we will see it to continue to evolve and continue to expand as the demand surges and we suffer more and more from these labor shortages. It's going to make sense for us to try and figure out how to augment in areas where we need to close the gap.
We kind of referenced this at the beginning. The maritime industry has heard about the promises of robotics and automation for decades. So, I mean, from where you sit, what makes 2026 different? And why do you believe, or do you believe, the combination of AI, machine vision, sensing, and computing power is finally reaching a point where autonomous welding can succeed in one of manufacturing's most difficult environments, which is, of course, shipbuilding?
Yeah, I would say I do feel like it is different this time and now for a lot of the reasons that we've been talking about for the last hour. The technology is very different even than it was 5 years ago, and it is accelerating at an extremely rapid pace. And I think that's going to unlock areas that we just were not able to use this technology for in the past. And I think when you combine that with this generational surge in demand that we have not seen in and certainly in my generation. And then you couple that with the technical capabilities now, and then you couple that with the labor shortage that we've talked about. Those are structural things that coming together it points to this is different this time, and we have to find a way to make this work. We have to find a way to make this work for everybody because otherwise we're just not going to be able to continue to compete. And we're going to see more and more of this type of work go offshore to other countries, which is going to be even worse for workers here in the United States.
Okay. Well, Heather, it's a fascinating topic. You are an incredible guest, and I truly enjoyed our time together talking about Path Robotics and just automation in the shipbuilding industry. I hope we have another cause to talk in the future again.
It was great. I really appreciate your time and I enjoyed it as well. Thanks, Greg.
Thank you for listening to Maritime Matters. If you would like to be featured on a future Maritime Matters podcast, visit www.marinelink.com or email maritimematters@marinelink.com.